So I'm very happy to introduce Peter, who's going to be speaking to us about deployment diagrams and explaining architecture and security. And so yeah, take it away, Peter. Thanks.
Okay, thank you. So in a way, what I'm going to talk about tonight is fairly basic stuff, right? Not really advanced or technically complicated, but there's a reason for that. And the reason for that is that this is not for communicating between professionals. This is for communicating to other people. So let's start with identifying who I think is in the audience, right? So you're either an IT architect or you're, I don't have a monitor here, or a solutions architect, risk analyst, security architect, or assessor, or anything that remotely resembles that. So who identifies with one of them at least? So that's most of you. So do you find it easy to communicate with people who are not in those roles? Who finds it easy to communicate easily with people outside of these roles? Okay, that's quite a bit fewer, right? And it matters, right? Because your influence, your power, even your job security, your business is directly proportional to how well you connect with the people that are dependent on your work or on whom you depend for your work. And I'll dive into a couple of examples of that, of how to do that, a couple of techniques for how to do that. And while they sound simple, there's devil in the details. And I think, personally, that the easier you can come across with your story, I mean, it doesn't look as exciting, but your counterpart will subconsciously thank you for that. Okay, now I understand. Now we can relax. Now I don't have to be on my toes all the time, or I can let my guard down a little bit. And what I'm saying is actually not that new, because it is stuff that I've been using for decades, right? I'm just telling you how to use this in an informal way that's still precise, and that helps you communicate with other people than your direct peers. And in a way, sometimes the beauty is in the simplicity. You know, one of my favorite composers is Burt Bacharach, who creates music that sounds so interesting and so simple and so. And if you dive into how it's made, you go like, oh, wait a minute, this is a little bit more complicated than I thought, but it's really accessible. Anyway, one of the reasons, or to dive a little deeper into that, one of the reasons why we want to talk about this is that you do have a position of power, and there's a couple of positions of power that you may have. And if you use that power properly, you're going to get what you want, and you will contribute to the greater benefit. And if you don't know how to use that, then you're not going to get those goals, or somebody else is not going to get those goals. And the key to that is often in communicating. So you need to understand what other people are doing, and other people need to understand what you are doing and what you want them to do. And for example, everybody needs to understand requirements and risks across a large estate of systems. By the way, I'll put these slides up on the page. I have a QR code on a business card here that you can scan. That will bring you to that page. So that's but you're totally welcome to take pictures as we go. Anyway, diagrams are a tool to communicate. We all know a picture can say more than 1,000 words, but a picture can also confuse more than 1,000 words, right? So, actually, I have what I talk about today. It's part of what I have in my book. That you can buy this on Amazon, but you can also download it, or you can review it for free. Actually, link on the business card. The book is just there on Amazon just for bragging rights, right? Not because I'm going to make any money off of that. Okay, so what we're talking about is deployment diagrams. Right, and they're known by many other ways, and there's variations of them, mostly a lot more complicated than what I do here. But the core objective of what I'm using them for is show allocation of functions, right? And that allocation of functions includes or even implies responsibilities for building, running, securing, and all of these things. And if we collaborate with other people, that means that we have to slice it up and make sure that everybody knows what they are doing. Now, today I'm focusing on deployment diagrams, but there are a couple of other techniques that are relevant in that, and they're in the book. The basic symbols, do they sound familiar? Right? Right. Unfortunately, I'm using them in a slightly different meaning. So the left one denotes enclosure, and I'll elaborate on what that means. And the right one denotes connection. Now let's take an example. Right. Over there you see web browsing. Now the diagram looks kind of familiar, right? You've seen stuff like this before. But what does it actually mean? Because we gloss over the meaning, and if we gloss over the meaning, we don't see the finesses, and we also don't see when the meaning is violated, so to say. These are enclosures, right? And they denote that somebody is taking responsibility for that. So I also call that basically I call it a control boundary. It's like something within which something or somebody has control. And in particular in the IT field, that means controlling the software and the data. So whenever there's a piece of data or a piece of software, and then the AI world, that's actually the same, you want to know where is it and who controls it, who in particular controls access to it. And as I said, the diagrams look very intuitive, but you want to check the details. Okay, here's the example that I've used to explain distributed systems design to my wife. Right? Now, my wife's a smart person, but she's not very technical. So the situation is probably familiar to many of you. You play music, music comes out of the cloud, right? You have your phone, you have your speaker. Those are 3 system components, and they're under 3 different controls. In a way, they're within 3 different control boundaries. How does the data flow? How does the data flow between these 3 things?
There are 2 flows. One is the actual stream, and the other flow is the control of the stream.
Right. And you're already making it more complicated than I need in my example, but you're completely right. Let's first look at how the music flows. Right? And indeed, it's a little bit more complicated. There's basically 2 ways in which this can work. Right? Music goes to the phone, music goes from the phone to the speaker, or music goes to the speaker directly. These are both valid architectures, and in fact, they both are both used. You have a question, comment?
So why would I really like diagrams, so that's why I joined here. And I'm an avid reader of Tufte.
Okay. Edward Tufte. Yeah, very good book.
So arrows have meaning. So why would the speaker send data back to the cloud?
All right. Yeah. So I've used a bidirectional arrow here for not a particular reason. Anyway, any protocol is bidirectional, right? If you stream data, then you're going to get some feedback back. You could. Well, okay. Here's the point, and now right now you are having a discussion that matters, and that makes sense to both people that are talking about it, right? So, case proven in a way. And why does it matter? Well, because with these diagrams, you can talk about, okay, what happens if I turn off the phone? Right? Does my music still flow? Right now. On the left-hand side, you immediately understand that it doesn't. On the right-hand side, it keeps moving on. And as a matter of fact, I used to have a Google Chromecast, and it was sometimes hard to stop that thing, right? Because you lost the control channel and it can't find it back. Now, the reality is a lot more complicated than this. But the point of a diagram is that you only need to elaborate it to the point that you need to make your point, or whatever the cases that you want to do. Okay, so this is distributed systems, right? And a few other things that you can talk about here is, okay, who has access to what? And then you're going to dive deeper. Who controls access? For example, how does the internet connect to the speaker or the other way around? How does that work, right? It matters. And so you have an account over there, you have an account over there, and the speaker doesn't really have an account, but you have joined it into your local network, and then there's some discovery protocol to make it a little bit more complicated. Now, again, the point I'm trying to make, or one of the points I'm trying to make, is that you can refine these diagrams to the extent relevant. Let's go back to our web browser example. Is that the whole story? No, it's not. The first refinement that you can do is, well, the DNS the address of the web server is actually looked up through DNS. And in fact, in quite a few scenarios, this has a big impact on which sites you can browse to begin with. And this is how you explain that. Or you can say, well, there's the internet as a... I'm really missing a monitor here. There's the internet over here. That's an additional component. And now you can talk about, okay, this connection exists, this may exist, this could be down one way or another. And maybe you have an additional cloudy thing in here that says local Wi-Fi internet. And then you can talk about where does it break down. And it helps you troubleshoot. Right? Now, you can get too refined, right? But again, you want to zoom in to the point that it is making your point. Okay, slightly more complicated example, and this is the one that I use to make 2 points. First of all, applications in the cloud are no longer server next finish ready. And also, okay, who's involved in all of that? The application is spread all over the place with multiple responsible parties. So this is an actual example from a cloud security training customer of mine. It's a Belgian bank. So you have a customer mobile that has an app. Now, the app talks to an Azure cloud database for one reason or another. That's all in the cloud, so that's on the top. And then on the bottom half, what you see is their data center. And inside the data center, there's a bunch of other components. Now, each of these boxes, right, contains data and contains software. Sometimes it contains a lot of software and not so much data, like the reverse proxy, and sometimes it contains a lot of data and not so much software, like the cloud database, or the other database for that matter. Now I always ask which component is missing here. That's totally relevant for the life cycle of the application, but it's a little bit of a guessing game. So, but it's the App Store, right, to make the story complete. And now you can talk about, okay, who owns which piece? Right, and who actually controls that piece, which is not necessarily the same thing. Which is a cloud service, which could be cloud service. Where's your sensitive data? And from there you can focus in and zero trust, on the data that matters and that you want to protect first. And this is a great way to sort of move your story through the entire architecture and have a great conversation with other people that have a responsibility somewhere in that picture. And that's the whole point. If they understand what they need to do, they can ask questions on how to do that, and so on and so forth. Okay, inside the control boundary, there's data, as I already mentioned. This includes the configuration of secrets. And those are the, what's the most valuable secret, right? Is that the company's database? I would say it's the password of the root admin. That's a more important secret than the company database, right? And how do you control that? And we'll see if we have time how that works in encryption architectures that can get really complicated in a cloud context. Software, AI models, anything that anything data. If it is a bit, it lives somewhere. That's the whole point. And you want to figure out where it is. And if you don't, what is a bit? I don't know where it lives. Then somebody is having a misunderstanding, right? Okay, starting point for analysis. The boundary controls, or the control boundaries, the boundary control stuff. Now, the circle, the enclosing thing goes by many different names, and my tip, use the words that your counterparty uses, because it makes them feel heard. So, control boundary, a perimeter, a policy, a network segment, whatever it is. And we'll see some examples in a second. So what kind of controls do we have? Well, in this particular case, right, the server here says, well, I'm only allowing HTTP or HTTPS or both to pass that point. And then you can go a little deeper, and let me finish the the story. Inside the machine, you have additional controls, right? The operating system decides what is the process that this connection goes to. And inside the web server, there's a control boundary that says, hey, you're not allowed to look at this file, or you are allowed to look at this file. And if you, who was at my Zero Trust presentation yesterday? A couple of them. Okay, and that guy as well. Well, that's the extension. This is where you link into Zero Trust. Because at each of these control boundaries, you can have a look at, okay, what is the reason why we're making this access decision? What are the tools for that access decision? And yesterday I gave the same example on retrofitting Zero Trust, and then I promised you can talk, you can listen to more stuff about control boundaries tomorrow, which is now. The idea here is that, let's see if I can actually, no, that doesn't work. So we have an application here, and the application lives in an execution environment, let's say a Windows server or Unix server, connect to a firewall, and you think, well, that's not good enough. Let's fix this, right? And then you can have a look at each of these control boundaries to see what additional stuff you can do there, what additional control you can imply there. And the example I gave yesterday is it's not just network security. You know? One of the biggest problems that we have is data exfiltration, right? That whatever is in the news, big data breach, right? Now, any malicious actor will find it really easy to get a couple of records out of a database. You just bribe somebody in the organization and you get specific information. That's not a big data breach. Technically it is, but it's not a big data breach. Big downloads, that's a problem, right? Now you can protect yourself better against big downloads than, or uploads as a matter of fact, than you know, we can make a distinction. You have to give lots of people access to individual records, but you don't want to give lots of people access to the entire download. So you can think, okay, that control boundary over here, I can talk about how we reduce large downloads. You know, and back in the old day, well, maybe this is a sidetrack, but this is an important. Who of you guys are in? Used to be in network engineering, right? Now, quite a few. So, when information security, or well, I should say, when cybersecurity started to become important, right? It was typically the network engineer who had to do all the security stuff. Remember that? All the other guys could say, well. There's somebody smiling in the back. I mean, it's a lazy application owner says, yes, too much access. Oh, you're a network engineer. Can you fix that? And network engineer is always a cooperative guy. And then he said, yeah, sure, we can. Not necessarily the best way to do it, right? Now, if you're a more mature architect, you can sort of say, well, you can do it over there, you can do it over there. That's a lot better and cheaper. So stop bothering the network engineer, right? And there's a couple more things that you can do, but that's more into Zero Trust. The other thing that you can use these diagrams to explain is that in Zero Trust people say, well, assume breach. Now, what does assume breach mean? That means inside your execution environment, there's stuff that you don't want to be there, right? And that means, you know, what about the access that stuff has, right? Now, of course, what you should be doing is reduce the access that the entire, you can this perimeter you can use to block all malware command and control traffic. You know, any server that has access to the real world is basically a serious vulnerability. And with AI, it's even worse. Let's not get into that. Then okay, let's not move to too many things. Now, anything can be a control boundary or an execution environment, and I'm just listing here a bunch of things. You don't have to memorize these. You can download the slides later. But if you start thinking about that, it all makes more sense, right? And then you can start look at, listen, I don't understand this diagram, and that's not because I'm stupid. It's because the diagram is wrong. Okay, I'm ahead of myself a little bit. So in every execution environment, there's data and there's code, and you may want to ask yourself how the code gets deployed. That's another interesting sidetrack, especially in the CI/CD environment. Now here's a diagram. Who's familiar with these types of diagrams? Seen before? Oh, that's not too many. Well, cloudcraft.co, remember that. It's really beautiful, right? And this, I mean, I don't have the time to go into it right now, but you can see about 10 or, well, maybe 20 execution environments, sometimes nested in other execution environments, and all of it matters. And you can ask all the time, okay, how do we get access there? I'm going to skip this one. Now this diagram is maybe too little, maybe too detailed, but what's wrong in this diagram? This is a official diagram from an official Amazon Web Services page that is now officially taken down, replaced by something that's better. But what's wrong here? At least from my perspective, right? Say again? The surrounding box contains elements. Well, you can have execution environments inside execution environments. That's not the big problem. The problem is that we have a router table here that's outside the router. So from a deployment diagram perspective, that's completely nonsense, right? Because it doesn't tell you how you configure the routing table. You need to have access to the router in order to manipulate the routing tables. And this diagram doesn't show that. Right, and therefore it's confusing, and this is not even a big confusing diagram. If you have a look at some of the Azure diagrams of their things, they totally ignore these types of conventions. A line at one end of the diagram means something completely different from the line at the other end of the diagram, and there's no legend, there's no explanation of that. And with what I'm telling you right now, if you apply that to the diagram, you go like, yep, now I understand why some people don't understand Microsoft. Okay, virtualization is nested boxes. No need to go into that in a bit more detail. Continuous delivery in DevOps is also really interesting because now there's an interesting thing going on in delivery, or in deployment as a matter of fact, is that there's a piece of data somewhere that becomes code somewhere else. And you want to understand where that is, and in addition, how the control boundaries are around that, and what are the deployment keys. And now you start manipulating deployment keys by software, and now it becomes even hairier, right? Because you need those keys. They have power. They give power to something, but it's not under direct human control. Okay, a couple more minutes, and then I'm going to wrap up, because I could go on for this like 2 hours. But then, if you don't like this anymore, just go away, no problem. One of the hardest things that I've encountered to understand, at least for a lot of people, is how does encryption in the cloud work? Proper, at scale, right? And it's not that trivial. It's not like, okay, I'm logging into the machine and uploading the SSL certificate or whatever it is. Manual thing doesn't scale. And this is the thing about cloud. You automate control. You even automate setting up control, which means that you manipulate or have software manipulate secrets that other software uses to get access. Okay, how meta can this get, right? How do you review that? Well, couple of symbols. So all of these are control boundaries. The left hand is the most left hand symbol is the simplest one. It's like, okay, you have text. The control boundary is basically the piece of paper that you write it on, because if you have the piece of paper, you control what's on there, right? It's as simple as that. And some of that, now your key is also a document. An encryption engine, we'll get to that. The key manager is control around a bunch of keys. And then you can ask, hey, who has access to the key in the key manager? That now becomes a sensible question. And you can actually point at where that question actually lives, so to say. Okay, here's an example encryption architecture that is from an older version of the Cloud Security Alliance guidance. Highly recommend that one. And what happens here is that okay, there's plain text coming in from the outside world. Let's say customer data, right? I want to store that somewhere on whatever, S3, right? So I need to encrypt it somewhere. Now, what we're saying here is we're using instance managed encryption. You could also have the encryption somewhere else. I mean, there's like 20 variations of this. And NIST has a document of 110 pages long that's full of stuff like this. So we can say, well, the encryption engine needs, that's the thing that converts plain text to ciphertext. Okay, but how does it do that? It needs a key. How does the key get there? Now we can have a look at a big control boundary around that. And if I manually set up a server, right? I manually boot up a server, I log into the server, and then I type the encryption key inside, then this is kind of what it looks like. And this corresponds to the Amazon Web or the Azure management plane, and this is my stuff. I could also do a little different and have some sort of automated key manager inside the Amazon infrastructure. But now the question is, what controls the access here? Because in the previous slide, I mean, you can see this crossing here, and you can, when you explain it, you go, yeah, somebody's logging in. So that's user level access control. But how does that work? Hold on. How does it work? Whoops. How does it work in this situation? Well, that's for further study. That actually has to do with service identities and roles, and there's a way to do that, but it's actually one of the more advanced or the less trivial features of Amazon. Let's put it like that. Okay, drawing tools. How do we draw this? Because you want to communicate, you got to draw. Really quickly, Sharpie also always works. PowerPoint, if you're happy with it. Mermaid is for simple solutions the best, in my mind, for a variety of reasons I'll get to. If it gets more complicated, then you can do a mermaid. The diagram is too complicated. It's more or less you're not getting your point across. There's a couple more, draw IOD2, and so on. And try this. There's a couple of ways of doing mermaid. But you can ask Claude or ChatGPT, hey, what kind of mermaid diagram would best represent this image? And you can actually shove the hand-drawn picture in there, and it comes out with a fairly decent answer there. Now, this is how mermaid works. If you have this diagram, that's mermaid. Any of you familiar with mermaid, by the way? Okay, good. Use Claude and ChatGPT to create that. That's always good. This is another type of diagram, a mermaid. Yeah, it's really good for simple stuff. And as I said, you don't want to make it more complicated than that. So we're nearing the end. I want to have some time for questions. Shameless plug is my book. I'm not selling it. You can just download it for free, but it has a great introduction into these things and a lot more. So the title is How Do Digital Infrastructures at Scale, right? Because that's the really interesting bit, lead to value, to risk, and mostly to power. Now, I haven't finished writing it, but it's already on Amazon. Hey, that's a minimum viable product for you, right? I'm planning to make this about 2 or 3 times the size. You can have a look at it. I have one copy. The others arrived too late back home. And again, the QR code is on this small little card that I have 100 of them, and they're specifically made for this show. So indulge yourself. So that's more or less a story. I've skipped over a couple of things. Maybe you have some additional questions on how to use this, and let me know how useful you find this discussion. And for those of you who really want to grab a beer, now's the time.
Yes, so I know that you wanted to skip on artificial intelligence, but
say again?
I know that you wanted to skip on artificial intelligence.
Oh, yeah.
Apologies for this, but I actually architect MLOps solutions. And now with the whole LLM ops, GenAI stuff, we kind of incrustate into normal machine learning architectures.
Yeah.
It's quite challenging to make it to such a way that it still makes sense, high level, but there are so many moving parts inside that if you omit them, you're also,
you're
keeping up
vulnerable.
important information. So what is the right level, in your opinion, in some complex things like MLOps, where you have to show the moving parts, when you have to show the back and forwards, yet remain simple?
Yeah. Well, as you said, the story is inherently complicated, right? That means that if you want to draw it out in all its detail, it's going to be a really complicated diagram. At the same time, the core components are quite simple, right? If you look at if you're using a random model, whatever, or Llama for that matter, you throw in an API request, a completion comes out. The model doesn't have any memory there, right? So you could talk about what's in that box. Well, in the box, there's a model, right? Next question is, how did it get there? But that's a different story. Then you can sort of have a boundary around that where you loop that result back, and that's where your chat history comes from. And additional context engineering. Where the context is also a box in a way.
Yeah, you need data, right? You need to feed data.
Yeah.
You have an output, fair enough.
Yeah.
But once again, the data lives in a place, the model lives in another place. You are serving it somewhere else.
Yeah.
So you see, you can go as high as you want, yet...
I think, the way I look at how AI security works is by using the exact same techniques, although it's a little longer than we have time for here. If you wish, we can talk about this in a bit more detail. I have some drawings in, where was that for? That was for a project I'm doing. What I also want to point out for those who are interested in this, there's a really great research paper by the Cloud Security Alliance that says security for LLM-based systems or something like that. And that really talks about how those data flows go and if you look at the boxes, you can easily see where you don't want certain data to be. For example, we know that the LLM, if the chat history, not the LLM itself, but the chat history can contain secrets, and you cannot use whatever is in the context window to protect those secrets. I mean, you can try, and 90% of the time it will work, but there's always a way to escape that. And that's much more true for AI than it is for any other piece of software that we have. So you can say, okay, if a secret happens to land inside the AI context window, then we have to be really careful where that potentially could go. And that's just a bunch of additional control boundaries. Does that make sense?
On the paper.
Is that okay for you?
Yeah, no, I think I'm interested on the paper you mentioned.
Yeah.
Probably we have to talk further.
Yeah, okay, good. Yeah, you know where to find me now. More questions. And okay, they really make you run, man. Now, in the distance afar, you can hear the kind of war zone sounds that, like yesterday, were more or less beneath our floor, right?
I'll have to be there in a few minutes, so
okay.
Thank you for the warning. I'm in robotics.
Right.
So we have a lot of moving parts.
Literally, right.
And I'm doing a lot of research on systems engineering methods in order to understand better, like, what do our clients want? Because with software, it's already a bit easier to change stuff than if you order hardware. So, and I was thinking, like, is your point that you want to have this diagram drawn, or is your point that you should draw diagrams anyhow?
Well, you should. It's a tool, right?
Yeah.
It's up to you to use the tool. If you find it useful, it's a good tool.
Yes,
right?
correct.
If you don't find it useful, get a different tool.
Okay.
Right? It's as simple as that. And what I'm showing you is how this tool actually works.
Yeah.
And what some of the pitfalls are of the tool, and also what are the benefits of the tool.
Okay.
Now, in the context of robotics and embedded hardware, the hardware itself is a control boundary.
Correct.
Unfortunately, it's a control boundary that is leaky in the sense that the hardware is out there in the field. So
Can
that's
be,
another
yes.
additional attack factor, so to say.
Yeah, but so I wondered, like, have you looked at so I get a lot of discussions like you just had with people, like, what is the scope of the picture and what is the system boundary and what are the interfaces? I mean, they could be thermal, optical, whatever.
Yeah.
So I was wondering, because I found a few years ago C4 diagramming, and I was really happy with it. It works really nice for the software part, a little bit less for the mechanical parts. But I thought, like, what is your opinion on that?
Well, what I said earlier is that I mean, there's a bunch of these diagrams here, diagram types. There's UML, and there's variations of that, and hundreds of them, right? And now Edward Tufte didn't talk much about those flow diagrams. He was more in the graphical representation of data. But sure, and they're all tools, right? The big distinguishing thing, I guess, that I started this presentation with is not so much about the expressive power of the notation, but about how easy you can explain it to your target audience, right? C4, enormous amount of detail and the precision, right? Like lambda calculus, but I can't explain that to my wife in 10 minutes.
If you take the top sorry. If you take the top level of C4, you can explain it very quickly. And then I think the point is that if you want to go deeper, then it allows to go deeper in skilled parts.
Sure,
and I think one of the points of the Simon Brown who made it was that a lot of the times architecture diagrams don't represent how the system is made. Like you get like a database thingy, but nobody knows what the database is or where the database is. So if something lives somewhere, it's like his point was that he wanted to have architecture diagrams that actually represent the implementation instead of represent a mental image.
Yeah, exactly. But I guess his objectives are very aligned with what I'm trying to bring you, which is give enough clarity so that you can have that you can have relevant distinctions between, let's say, responsible parties, because in the end that is what allows us to collaborate. Like good fences make good neighbors, right? What's different about that is the level of, let's say, symbols and coding that you accept as being part of the common language between you and the other person. I have two symbols, right? 0 and 1, right? If you cannot explain that, I mean, you can literally explain that to anybody who has basic competence in language, or, right? I mean, I cannot think of anybody who would make a professional who would not be able to understand that in a couple of minutes. Whereas the more, let's say, advanced diagramming techniques are very relevant, but for a smaller audience. So your mileage may vary, as they say. Does that answer your question sufficiently? Yes. Yeah, it's a tool. Sometimes I need a hammer. Sometimes I need a laser cutter. Yeah. Okay, more questions?
I've got one, actually.
Okay, sure, go ahead.
Talking about setting the diagrams to your audience, who may be senior management or maybe different people in a company. If they, just trying to think of a nice way to say it, if they're possibly not as technical or not as smart or not as...
or whatever the word is.
Yeah. If they're not quite understanding things as much as you want, is it right to oversimplify or should you educate people? How do you get that? I don't know. Do you know what I mean?
I'm not sure. I've completely.
How do you pitch it right for people if they're not too technical and you're trying to potentially inform?
The day before yesterday, I did a course or workshop, as a matter of fact, on public speaking for technical professionals, and one of the core items there is whatever you communicate to somebody or try to communicate to somebody through a speech or a diagram, or whatever it is, they are at point A. And your story is supposed to bring them to where you want them to be, which is point B, and you want them to do something there, call to action, right? The diagram can be a tool. Now, in a conversation, you actually have a feedback loop. So you go on and on and on until the other person gets the point that you're trying to make. And in the hierarchical construct, where you are in one of those positions of power, you're neither at the top nor at the bottom, you want to understand what the people that are more detailed are doing, or what you want them to do, but you also want to communicate that to, let's say, more upper management, which are typically the ones that are less tech savvy, but they hold the strings to the money machine, right? So you want them to understand where the money should be flowing and what assignments people should be getting, and they should be comfortable with that. And if they feel that they're comfortable with those agreements, or with those diagrams, say, oh, everybody seems to understand that. Okay, you need that, Yep, just go. Then you have reached your objective, which is to bring them to the point where they give money and instructions and have your back when you get into trouble.
You use a diagram to tell a story.
Yeah, it's telling a story. Right, in a way it's telling a story. Now we could talk about story techniques, but then we have to have a beer. Okay. So we're already 10 minutes over in overtime here, but apparently you liked it, or at least most of you. Yeah. Any more questions?
That's it. None from the back? No? Okay, thank you. Well, in that case, thank you very much for a very...
Okay, you're welcome.
Thanks.